Well, thank you for your patience here as we got our things together. It's been a couple of months, so we haven't seen you. Hello and welcome to the January 2021 Pre-Hospital Care Research Forum Education Research Journal Club podcast. It's been since October because we had the holidays for 2 months, so we're really looking forward to welcoming you to 2021 with just a terrific, timely topic for today. The Pre-Hospital Care Research Forum, as you know, is dedicated to the promotion, education, and dissemination of pre-hospital research. We believe that it is the responsibility of emergency medical professionals worldwide to build a body of evidence to examine pre-hospital emergency care. Now, together with the National Association of EMS Educators, the PCRF promotes research literacy and advancement in the science of EMS educational research. Here with the PCRF Journal Club, we take a closer look at some of the latest research happening in medical education. I'm Megan Corey, and I'm here with David Page and Dr. Bill Toon. And today we have a guest with us too that we'll introduce in a few minutes. The study we will be reviewing today is Getting Students Back on Track: Persistent Effects of Flipping Accelerated Organic Chemistry on Student Achievement, Study Strategies, and Perceptions of Instruction. This is a study that was published online, comes out of the University of California at Irvine, and we also happen to have Dr. Renee Link, one of the study authors, here with us today to help us understand this research and the outcomes. And we're going to bring her in pretty soon here. But first, we want to remind you that we do have our news about our upcoming call for abstracts. As you know, each year, the call for abstracts highlights what we do at the Pre-Hospital Care Research Forum. Abstracts are received from EMS providers, clinicians, educators, and even students from all over the nation and abroad. Peer-reviewed process determines which authors are going to be invited to present their studies at the national conferences or even an international conference. This year, the call for abstracts for education, clinical, and systems abstracts are on the same date. This is June 30th, 2021. That's when they're due. You're going to submit them online. You can go to our website for more information, or you can email pcrf@mednet.ucla.edu. So we look forward to seeing some of the research that's going to come in this year, in particular because of all the things that have been going on over the past year with COVID-19. So thank you all for joining us today. Let's begin, and we want to remind listeners that you can use the chat feature on your screen to type in questions and comments. We'll bring those into the conversation as we go. And because we have a topic on flipping the classroom, we know we have a lot of flippers out there who've done this and some research on this in EMS. If you have a longer question or you'd like to engage in a little bit of discussion, just send the organizer a quick message in the chat, and we'll unmute you and bring you into the conversation. So, organic chemistry. This is a difficult gateway course into the STEM fields, and we know that prior research has shown equity barriers to completion for first-generation, low-income, and persons excluded because of ethnicity or race, and women in STEM degrees. Major science courses like organic chemistry are still taught predominantly through the traditional lecture mode with very minimal interactivity. And we know that the result then is what these authors describe as a cultural mismatch. So for those who are more likely to succeed if they are part of an interactive community of learners. So this research group looked at the impact of implementing a flipped classroom model on outcomes of students enrolled in accelerated organic chemistry summer courses over 5 summers. So I'm going to just go ahead and bring the author in here. Dr. Link, can you hear us okay?
Yep, I can hear you fine.
It's great. Great to have you here. First of all, congratulations on your paper and on your research, and such an important topic, and we're really grateful that you're here to join us in this discussion today. Could you begin by introducing yourself, telling us kind of your background, where you're from, and then how you landed on equity in education as a subject for research?
Sure, I am Dr. Renee Link. I'm a faculty at UC Irvine in the Department of Chemistry, and I'm in a professor of teaching role, which is a regular academic senate level position, but my job is more focused on teaching than research. We have these roles in the UC system, so those of you at UCLA might be familiar with it. but a few other places as well. So I spend most of my time teaching, mainly organic chemistry lab, actually, even though this is a lecture course the paper's on. But I do a little bit of scholarship on the side, essentially.
Great.
Where I'm from, all over the US, if you want to know where I'm from, you'd have to pick a year, and I'll tell you where I lived. But my background is I'm a first-gen college grad. Nobody in my family went to college. My mom actually is an RN who graduated from her RN program at community college the same week I graduated high school. So we actually graduated together.
Wow.
So I had great grades for college and zero money. So I moved across the country with a friend to California and went to community college in San Diego, then to UCSD to finish my bachelor's, and then to UC Irvine, actually, where I still am for a PhD. And in that process, I didn't realize I was taking a different path until I really got to grad school. That's really where it became obvious that I was like, oh, okay, I'm not exactly the normal person here. All right, good to know. And I really just thought about my experiences in classes, and I thought, I think we can do a better job here. I had to work all the way through school, so it was really hard for me to stay awake in a lecture class. I'll be completely honest about that. I hope none of my former professors are listening, but I often nodded off in class, partly because it's hard for me to pay attention, just more than 15 minutes or so, and partly because I was often sleep deprived, as many working students are. So when it was my turn to teach the classes, I thought, okay, I'm pretty sure we can do a better job. I think there's something we can do differently here. And the flipping idea was just starting to become popular right as I was beginning my career. So that's kind of where I jumped into it.
Very interesting. Did you study education at all, or educational methods, or
Nope.
equity? So you just
Um,
knew sort of from your own experience, or had an idea.
I did take some pedagogy related courses and programs as a grad student because by about my second or third year, I knew I wanted a teaching focused career. So UC Irvine has a pedagogical fellows program for their graduate students, which is really great at preparing you to think about teaching and think about teaching as a practice, not just as something you show up and do. So I had that training, but on the research side, not at all. And in fact, my co-authors on this, I appreciate being called a research group, but we're more of a little collaboration. So we're all doctors at this point. But Wendong, he was a grad student at the time in the School of Education. He's now faculty in China. Lynn Reimer is our education specialist. She was also a grad student at the time, but now Dr. Reimer. She is working in K-12 schools now. And Cameron Denaro is our statistics specialist. So her PhD is in stats. So it's really more of a collaboration of me going, I want to do this thing, and I think it's important and matters. Also, I have no idea how to study this. Please help me.
That's great. Now I can hear Dave sort of smiling across the
I
waves.
love Renee's humility. You're just such a breath of fresh air. It's amazing to find someone with your depth that just kind of goes, well, I just kind of, I picked it up and I asked some people for some help. And I think, EMS people are like that. You're just, you're supposed to know what to do. You're in the middle of an emergency. You just kind of look around and go, well, maybe I can fake it. Maybe not.
Yep.
Can you help me? How do you do this right? And I think you're the example of how to do that in research, and so glad you could join us today.
Yeah, there's another thing that you said in there too. You talked about this being a collaborative group. So I think that's important because on this podcast, we like to do a little bit of teaching about research. So as we go through your paper, we're going to talk about some of the tests that you used and why you chose your design and that kind of thing. But something that you said, we aren't some formal group. We didn't really study education research. You were prepared pedagogically, how to consider and think about teaching and reflect on teaching and learn different methods. But in terms of taking that to the next step to research, we've been talking a lot about this on this podcast about how to get a network of educators to get together and just study what we do together. And that sounds, what you just said is exactly what we've talked about a lot here in EMS, which is how to form a collaborative group and just look closer at something that you think might make a difference in your students and in equity in particular. So that's great. So can you give me some background about why equity? I mean, you say from personal experience, but you had to have done what, when you're interested in something, you do your lit review, right? And start looking at what's out there. So when you started to do that, why did you land on this model or these research questions that I have posted up? I've got a few slides here from your study, and so we have your research questions posted up here.
I think the equity background was less about what's out there because at the time that I was starting this, there wasn't a lot focused on organic chemistry. People tend to shy away from it a little bit because it's a harder class. You'll find a lot more on general chemistry than organic, although it's starting to become more on organic now. But I was also, a lot of it was just that I was teaching a summer class. And our summer class tends to be divided into two populations. It is students who are trying to get ahead and students who have failed the class before at least once, sometimes more than once, who are trying to get back on track. And that's two very distinct populations. When you're teaching the class, it's really clear that you are teaching two groups. And thinking about, what we're doing here, if you keep just doing what you were doing in the regular term class, and you have students who've already failed that regular term class, is this helping them? And then when you start thinking about who ends up in repeating classes, it often then becomes an equity issue because of all the institutional and structural barriers that are in place to really make it difficult for different groups of students to succeed. And I saw this myself because, remember, I said I went to community college. I went to Southwestern College, which is the last college before Mexico. I was very much the minority there as a white woman, which was fine with me. And then I got to UC and I was not the minority anymore. And I noticed that immediately, and that stuck with me. And so I was thinking with all of those things as I was kind of thinking about how do I design this class in a way that I think will just help students across the board and not just replicate the same issues that are just seem to be in place in classes all the time.
Yeah, and you use the term institutional or structural barriers too. So we'll scratch at that a little bit. But let's look at your research here. So you wanted to, as you mentioned, you specifically wanted to look at the summer course. I thought that was actually really interesting. At first, I thought, why organic chemistry, such a high level kind of course, and then why summer? But then as you described it in the paper, the repeaters and non-repeaters, it really does kind of divide into two very distinct categories in summer. Somebody who has to repeat, or what someone might say remediate or repeat, and then other students who are just trying to get ahead, which you would tend to think would be more on the self-regulated, high level kind of students. So that's I'm sure the gaps that are seen, and you can see that in one of your slides that'll be coming up, one of your figures, are pretty large here. So the first question, how do students' academic performance in accelerated organic chemistry 2? So tell us about why you didn't just choose one course to look at. You wanted to look at those who took organic chemistry 1 in 2 different formats, whether it was flipped accelerated or traditional accelerated in summer, and then their performance in organic chemistry 2. What led you to that rather than just sticking with, looking at organic chemistry 1 and performance?
The initial thought, I'll be completely honest, was just practical, in the sense of I'm the person who taught the organic chemistry 1, that's me. And I have a colleague who is teaching the second class, and we were always teaching in that order over this 5-year span. And I kept tinkering with things and changing things. So I was using different exams, different exam formats, playing with things across the board and changing the structure of my class. Whereas my colleague is, much more senior to me, and she kind of has an established method, and she was using the same exams that the students didn't have access to for the finals. They didn't have access after they were graded. So we had a nice, neat comparison by looking at those final exam scores in the second class, because it was literally the same exam. So just getting rid of a lot of confounding variables there.
Yeah.
helped to do that initially. But then as we thought about it, we also thought, you know, this is good from a practical standpoint, but also we just don't see anybody looking at that very often. There's a lot of focus on what happens to the students in the class that they're in.
Yes.
But I think that one of the things that happens when you change a class structure, whether it's flipped or bringing in things like metacognition or these things that help to build not just understanding the content of the class, but also study skills or time management or just how to approach learning that maybe students haven't seen before, that should carry over into other classes. At least we hope it would.
Oh,
And
yeah.
so we're kind of wondering, like, all right, are we doing something here that's going to carry over into a future class?
So we're talking about two things then. One is persistence, right? So their ability to continue and persist. So it's a longitudinal outcome. And I know you noticed you did a great introduction and review of some of the existing literature and then led to those gaps, right? So for those who are thinking about doing research out there, you look at your background and you look up the existing literature and then you identify gaps. And one of the gaps is very few, if any, have looked at longitudinal outcomes, and nobody had looked at longitudinal outcomes in organic chemistry. So you're filling a void here through your research by not just looking at this one course, but looking at how did they persist and how did they perform later. So almost a transfer of learning. Also, you could actually, if you looked at students and performance in other courses that they had as well, besides organic chemistry, you might do that too. So and then this is again a comparison of the flipped. But the other thing I liked about your design is you did qualitative and quantitative. So you not only looked at the, test scores, GPA, and other performance measures, but you also, surveyed and did Likert scale, which is quantitative, but also the evaluation of comments, which is qualitative. And then this was 5 summers, correct?
Right, it's a total of 5.
Yep. Mm-hmm.
Yeah, it's a total of 5, although we really focused on the last 3 because that is where we had the exact same final exam for the second quarter or second term class.
Okay, so I have this slide up that shows the model. Basically, you had this figure that shows the course and exam formats for summer Organic Chemistry 1 and Organic Chemistry 2 accelerated courses in the summer. So first years 1 and 2, I think you would also mention that I think the Organic Chemistry 2 teacher was the more experienced teacher, correct? They had 10 plus years of experience, and the Organic Chemistry 1 teacher was less. And I'm assuming you were saying that's you.
Yep, that's me. I'm fine with it. Yep, that's me.
You're in blue. Yeah. So so that's, and that was kind of a year of getting up to speed, or whatever you want to call getting your
a run-in period
yourself. Yeah, exactly.
Yeah, getting comfortable with it.
And then year 3 was used as your control. And then 4 and 5, you had the flipped model versus the traditional model.
Right. And since we had the data for those first 2 years, we did actually run the same models on those years. They're in the supplemental. So you see the same trends in the data. It's not as it's not as, I don't know what the word I want to look for is. It's not as great of comparison because we are changing exams, which can add a confounding variable, but you do see the same general trend in the data when you look across all 5 years.
Okay.
Can I just say also, we briefly mentioned table 1, where you did essentially a meta-analysis. It's like a systematic review within a paper, and you're listing 6, 7, 8 different studies here, adding up to thousands of students, comparing what happened when they did either partially flipped or fully flipped. So increased grades, and so in terms of your design, did you look at some of the ways in which people were partially flipping versus fully flipping to sort of inform this? Because you were very methodical here over the course of a long period of time. Our listeners probably envision studies that might, go over over a single course or several, but this is a long-term commitment to this. So how did you think about this when you started?
So actually, this was done before those other papers. It's just taken us this long to get it out because my lecture
Wow.
course, and this is the smaller part of my job. My main job is that, and David's heard this before, but the only sad thing is I don't have you on video, so I can't watch all your faces as I say this. My full-time main job in my teaching is to run the organic chemistry labs, which means I'm teaching currently this quarter. I have a 1,400 student class. So that takes up most of my time.
1,400
I will
students.
never complain again.
Yes.
Yes, my current class, this is winter quarter 2021. I have 1,450 students, 36 TAs, 2 head TAs, a stockroom manager, 14 learning assistants, and 2 peer tutors.
Oh.
That is my class right now.
OMG. All
Yes.
right.
So, this I had to work on this kind of on the side while I was doing all of that.
Yeah. For a side project, it's like pretty major.
Right.
I do want to, Bill is in here too. Dr. Bill Toon is on with us, and I know Bill has always mentions when we're discussing the kind of details of how educators teach, and I think it's really important to bring in when we say flipped, and I think you're getting at this a little bit, Dave, and maybe Bill, you can join in. When we say a flipped classroom, that means different things to different people, and some people have oh, I've tried that and it didn't work. I think it's really important to look at the theoretical framework here too when it came to what kind of things were used in the flipped environment, not just that you flipped the activities and that was it, right? So the culturally responsive teaching, the two pieces of the theoretical framework that informed this were culturally responsive teaching and social and academic integration, which means that there were these activities that were specifically designed to create a sense of belonging of all students. So although I really would love to see a video of people acting like molecules and whatever there was one activity in here that I was like, I need a visual of this, of some examples of some of the things they were doing in class. But I do think it's important how the learning activities took place is probably just as important here. Bill, are you on?
Oh no, I was listening, and my question is that did you think the question is, did you get better with your flipped classroom when you went from year 4 to 5? Do you think 5 had you were just more experienced with it, as well as the people that helped you do it, certainly than you were in 4? So did you learn things in 4 that it helped improve 5?
Oh, absolutely. One of the things I learned pretty quickly was that, again, teaching these 2 different groups simultaneously is really a challenge. And so I had designed some activities to do in class that were centered around things that I knew students struggled with in organic chemistry. But what I didn't do in year 4 that I did in year 5 was add some extra for those really really advanced students who are taking this to get ahead and it's all making sense to them. They were getting bored, and they let me know that in year 4 very vocally. So in year 5, I actually added some extra problems at the end of every week or every class period that I had to put a lot of superlatives in the name to make sure everyone understood that these were extra. So they call them extra super bonus challenge problems. I wanted to really drive home the fact that this is extra. If you can't do these, you're not failing. It's fine. But I added some really challenging problems and said, okay, if you have finished everything else while we're still as a class working together on these other things, I want you to try these extra things and see how far you can get. But then constantly reminding everyone else that like, it's okay if you can't do these super hard problems. You're not supposed to be able to do them. It's okay. And so, yeah, like just little things like that of reminding the students also why we were doing this. There's a misconception students have about flipping, that it's somehow less work for me when it's actually far more work for me. Like from a student perspective.
That was going to be I wanted to just add in there, tell us about how much more it takes to do this than traditional.
So the biggest time investment is getting it set up, because you're making videos and things like that. If you choose to do videos, I do. because I know that some people are fine with reading, other people it helps to have things explained. I also know that I can explain things in different ways than a textbook might, that might help, from years of being a tutor and being a graduate student teaching assistant. So I have kind of my own ways of explaining things. So I did videos. Those took a lot of work. Designing the activities can take some work, but once you get a good set, it's not too bad. But the difference is in the classroom itself. It's actually a lot more fun in class because the students are working, you're moving around, talking to people. If you're stuck doing it in like traditional lecture hall, you're like climbing over chairs to get to people. It's very exciting. We have a new classroom building that unfortunately we're not using right now that is designed for active learning, and it's so much easier to do in those rooms. It really does help. Whereas, you know, we can give a lecture, but if you've been doing a lecture for a long time, it's actually not that much work anymore. You know, like, you know the
Yes.
material, you kind of know what you're going to say next. And I don't know, it's once you get the flipped class established, like getting it established is a lot of work, but once you get it established, you're going to get your step count in during class. You're going to be all over the room, moving around, talking to people, and it's fun. I don't know how else to describe it than it's just fun, and it goes by so fast.
And I think there is this perception from students. You mentioned something that I think is true. There's a perception, and we actually have seen this in educational research, you know, survey results from students, that if it isn't feeling like it's, you know, really, really hard, then it isn't learning, or that I need to read and reread and reread in order to learn something. And we know that the results of things like that, of studies that are based on comparing traditional, what people perceive as good study habits or good methods of studying for an exam or learning, are not supportive of long-term retention and outcomes. And you mentioned something too about your courses and some of your maybe more accelerated, you know, students that are coming in that weren't repeaters, maybe saying, well, you know, we need more challenge. And I'm really glad you mentioned that the learning outcomes of a course are the learning outcomes of a course. This is the level that you need to be in order to pass. And if they want challenges, you gave them those extra opportunities and made sure they understand this is extra when you look at the outcomes of this course. So that's something I think that's important to remember for any level, that, you know, that's why we develop learning outcomes, to say this is what we expect that each student will be able to do by the end of this course. So that was just such a great point that you made.
Can I jump in here and ask, because I'm just dying to shift the conversation a little bit into this theoretical framework that you used, and just in terms of that activity, because it makes me think of how the course structure is or is not a cultural mismatch. And so in your paper you wrote, you know, certain groups of students are disadvantaged because of conflicts between implicit expectations for autonomy in the American higher education and cultural identity in American higher. So the question I have is, in this format that you're describing, in this activity and responsive environment, the obvious you know, question is, you know, do the students enjoy it? Do they of course reach the learning objectives, as Megan was saying, and was there such a in the cultural fabric, as you describe it, into these students who are typically struggling with this, you know, success piece? I love the DFW acronym for drop, fail, withdraw, and the peer acronym for those persons who are struggling. How do you reconcile that need for cultural connectivity with some of these activities? Was there a difference between those cultural groups identifying with that?
So I don't think we looked for any specifics on that, so I wouldn't have any data to point to. But I can give you an example from just talking with students in my lab class this week. I've been talking to some students who are struggling a bit already. We're 3 weeks in, and I keep hearing the same theme. I don't ask questions and I don't ask for help because I assume I'm supposed to just be able to read it and look at it and get it. And the people around me seem to all be doing that. So clearly I'm the problem. And I keep hearing this. And so by structuring a class in a way where we take the content delivery outside the class, because that's honestly not where students need us really. I mean, there's a million ways to do content delivery that doesn't require me specifically. And put my focus on helping them figure out what they know and what they don't know, helping them when they hit misconceptions, normalizing that other people are struggling with the exact same problem because they're right next to you doing it and you see them struggling with it. I think that that's where I can make a bigger difference than by just giving a very nice lecture.
And do you think those students of non-Caucasian or minority backgrounds, do you feel like they identified culturally better with their Caucasian peers? Did they feel more integrated at that point?
Again, I don't have any data that I can point to there, but what I can say is I do find that a lot of students don't know other students in their classes at a big university, for sure. I mean, our population is about 32,000 students. You would think, people would know each other, but maybe if you live on campus, you do, but if you don't live on campus, maybe you don't know anyone. So by encouraging group work, if they want to, I always give the students the option to work alone because we also have to consider, not everyone's an extrovert who wants to talk to people constantly. But encouraging connections between peers, you would see students start to form kind of their own groups, and you'd hear them say, you know what, do you want to work on this same problem outside of class? I still don't get it. And so I think maybe removing some of that barrier to start forming the collaborative work groups helps.
Yeah, and for our listeners, peer here has two meanings in this paper. One is peer is an acronym for persons excluded from science because of ethnicity and race. And so it's kind of an interesting acronym to put juxtaposed with the concept of peer learning, improving or having a better outcome for these peers, these persons that are normally excluded. I think EMS has a lot of persons excluded from EMS because of ethnicity and race. And so, I don't think that's earth-shattering news, but you got to call a spade a spade. This kind of methodology is very curious to me as one of the ways in which people could feel more part of the educational process.
I have a quick question about the DFWs too. Are they grades of Ds, Fs, and withdrawals? That's how I've heard of it traditionally, because that would be very different if there was a drop included in there. Is it Ds, Fs?
Yeah, so we don't have, it's actually a little bit difficult for students to drop our classes for the reasons, institutional rules. So we don't get a lot of Ws actually, or drops at all. Any drops for our class have to happen in the first 2 weeks. And for a summer class, I think it's not even 2 weeks.
Okay.
So they wouldn't even have gotten included at all because they were just never really there. So yes, for us, this is anyone who earned a grade below a C-. A C- is the minimum to move on to the next course in the sequence.
Okay, that's an important point to know, because if we were looking at these tables, table 4 and table 5, which have the accelerated enrollment by how many repeaters, non-repeaters in each of the level years, and these are the study years in table 5. If there was a category or a group that was able to drop, then that would be an important group, right? That would be another area that might have limited your ability to look at this. But because of institutional rules, it actually makes the group a little bit more powerful in terms of your results. So can you tell us then anything surprising about looking at your groups of repeaters, non-repeaters? And this is where I think, Dave, what you were getting at was we're looking from the category of repeaters and non-repeaters, but when you look at the demographic features of repeaters and non-repeaters, you can see differences in, from everything from female to persons who are excluded by ethnicity and race, first generation, certainly low income, initial SAT. And, you know, of course, you mentioned it later in your paper, but I thought, wow, those are high SAT scores for just anybody getting into this class. And then the sample size. Anything different from what you anticipated when you looked at these groups that were your study groups?
One of the things I was glad to see that the peer group was not overrepresented in the repeaters. I was concerned that that might end up being the case, and it wasn't, so that was good. I was not surprised, but the female group, and again, we're using female here as biological sex. I just want to make clear on that, because at the time that we have institutional data, the UC, or at least UC Irvine's data collection, was just binary biological sex. So it is a stand-in for gender here, although it is not gender, which means trans and non-binary are not represented because of the data limitations. But I mean, 73% repeater female is a lot.
Yeah.
And this was an interesting, I had a conversation with a colleague who said, but all of my top scoring students are women. And I said, okay, but what about all your students who are failing?
Yeah.
And when she went back and looked at that, she saw the overrepresentation of female or women presenting students failing.
That's such a great point, because we do have rose-colored glasses as educators sometimes, you know, and I've had conversations with my colleagues sometimes at school, and someone will say, I think, you know, people are doing great. I hear great things from students. And I always ask, do we survey every single student? Are we hearing from all of the students? Or, and actually, I think Art Sia from Santa Rosa Junior College. Hi, Art. He's saying, yes, experience with silent students is the same that you see in medic groups in our paramedic classes and EMT classes. It's very true. And we really have to be purposeful, deliberative about, you know, looking at this as educators, looking at each and every student and their experience in order to pull that out. Otherwise, we do tend to make these immediate, you know, assumptions.
I also like in this table just that.
Oh, sorry, I'll go back.
The flip group does not appear to be, you know, when you look at comparing two groups and whether or not one intervention is working, it just really looks like that your percentage of peers really remained relatively the same, and the first generation students increased. So if anything, in your flipped, you had a bigger challenge by just having first generation students. So it's nice that you had that, just so that we can see the populations.
Okay, I was going to jump to the results because these next two are just probably the most compelling tables. And then I am going to ask you to explain the little statistical, the linear mixed effects model. But let's start with the exam scores here. This is the table that has grades and pass rates for the Organic Chemistry 2 students who took the traditional versus the flipped format. So Renee, could you explain to us what you have found in this table? Again, we're teaching some people how to kind of read the research results.
Sure. Sorry, I was muting because of dog noises in the background. the 2020/2021 were free to mute before your dog makes noise challenge. Okay, our table here. Right. So initially, we had only looked at the second term class exam scores, but then we said, you know, let's look at some of the other things. We looked at the midterms and the finals. That was our first pass at the data, and we were seeing that, you know, you've got a pretty good gap in the exam scores. So we scaled it to be out of 100 points, which is not what it actually was, but, you know, we just divided it to make it easier to use. Just a heads up, everyone freaks out about these exam scores. So welcome to organic chemistry, where often a 60% is a good score. I know that sounds terrifying, but if you think that's bad, let me introduce you to physical chemistry, where like 50% is a guaranteed A. So
they have a bumper sticker. I see it. I
yes,
survived PChem.
I passed PChem. Yes. Right. So even though that looks scary, that's actually a pretty normal thing. So the non-repeater, so class average was 51 per 50, about 51, right, on the OC2 final exam. So I'm looking at the third row here.
That's this one here.
So I'm looking at the final, just to be clear, I'm looking at the final over the midterms because the final, again, that was that consistent exam that was the same for all the classes, all the years. So whereas the midterms were similar but different, you know, you try to write a really similar exam, but we all know there's always some differences there, right?
Yeah.
Like the question you think is equally difficult is not equally difficult. So, but the final exam is literally the same exam across all three of these years.
Okay.
So the class averages stayed pretty similar. So 51 versus 48, that's, you know, pretty close. But if you look at the difference between the groups, we go from almost a 30-point difference, 60 and 33 for non-repeaters and repeaters. So first and second column of the third row. There's a pretty big gap there. Yeah. And then if you look at years 4 and 5, that gap shrinks significantly. Now we did notice, yes, the non-repeaters seem to be going down a little bit, but when we did significance test on that, it was not statistically significant change for the decrease in the non-repeaters.
Great.
Was just due to variability.
And then we have GPA, the course GPA.
Yeah, so after we saw these exam scores, we said, you know what, let's look at people, like how they do overall. So we decided to go with course GPA, just converting the A, B, C, D. We do plus and minuses at UCI. So we have an A plus is the same as an A numerically, but all the other plus and minuses are actually different numerical scores. So we looked at their course GPAs, and then we said, you know, we may as well throw in my class as well at that point, because we're just looking at their overall letter grade in the class. And so in both classes, you can see there's a distinct difference in the traditional year between the non-repeaters and the repeaters. And so there's about a 0.8 difference in my class, and then an even bigger difference in the second quarter or second term class. And then we switched to the flipped, and remember, this was flipped in my class only, and that gap is essentially gone, or at least significantly narrowed, gone in my class and significantly narrowed in the next class. And you can see that reflected in the pass rate for the second class as well.
The pass rate is just, I mean, this you know, second to last, that is just so compelling, looking at the shrinking. And then you have a visual representation of this here, right? This is your visual representation of what we see in the tables, correct? So we're seeing, I love this figure. I don't know about Bill, you and Dave, but this is, I like this because it's a visual representation of the gap, of what we're looking at as the gap. So this is your traditional, and then you're flipped, and you can see the narrowing and disappearance of the pass rate is probably the most compelling for us. We, you know, in our field, we tend to have, you know, the threshold. You have to meet a threshold and then you pass. GPAs and grades and, you know, may not be as relevant in an EMT class or paramedic courses as they are maybe in the sciences, where you might be applying for something at the next level, a medical school or something like that, where a GPA may matter or a grade might matter. The passing is really the key. So I don't know how that is in organic chemistry. Is it, you know, similar or the same? Because this last, the one on the far right, the gap disappearance in the pass rate is very compelling.
Yeah, when we actually pulled that data and saw that, I just sat back for a moment. I was like, oh, wow.
Yeah.
Because the passing, I mean, okay, so the GPA matters if you want to go on to medical school, dental school, graduate program in a science for a master's or PhD, then your GPA matters. But not everyone wants to do that. And some people just want to graduate and go get a job, which is perfectly fine. And the passing is what lets you continue on or not. And this is not just organic chemistry. And maybe if you're not familiar with, you know, some of the degrees that the students in this class would be pursuing, most of them are not chemists. These are mostly biology majors and pharmaceutical sciences majors. You know, it's only a small group of chemists. Chemists are a very small percent of the population. in general, not just in my class. So it's mainly, we have a lot of biologists in here. And if they don't pass this class, not only can they not continue in organic chemistry, they can't continue in some of their biology classes either.
That's
So
right.
this is the difference between continuing in the STEM field or not.
Well,
and the medical field in many
and the
cases.
medical field.
Right.
Yeah.
Or really, or it's like do you stay in a STEM field or go and then possibly go into medicine, or do you end up shifting directions and going into a non-STEM field? Which, if that's what you want to do, that's a great option. But is it something you're wanting to do, or is it something you're being forced to do because of the way the classes are structured that are making it really difficult for you to pass them?
Wow. So before we get into some of the limitations and questions about that, can you help us understand what this effect size means in this next table? So this is your table 7, the linear mixed effects model for those years of study, the years 3 through 5.
Sure. So this is going to be where David's going to appreciate my humility again. I have taken 0 statistics class in my entire life.
Oh,
Yay,
we love you.
you're just like
We
me.
love you. Because I usually need, like, where's Remley? Where's Tony? Help me with this.
So one of the, I'll just tell you a little side story here. So like I say, Cameron Denaro, she's our statistician. She has a PhD in statistics, and I often have to be like, Cameron, you need to bring this down to my level again. I know how to do a t-test, maybe. That's it. You know, it's fun. I have fun with my biologist friends. They're like, you didn't take statistics, and I'm like, you didn't take quantum mechanics, you know?
Yeah.
You know, hey, watch it. You know, but one of my proudest moments ever is I actually wrote one of the sentences the paragraph that comes after this table.
Yes,
I actually
love that sentence.
I wrote a couple of these sentences, and I wrote them, and then I had her come back and look and like, did I do it right? And she just had to fix a couple small things, and that might have been almost as important as finishing my PhD, being able to write those 2 sentences.
Well, for those
going,
who are, you know, who are looking at this and wondering what that that R squared of 0.24 means according to the paper, and the sentence that Dr. Link wrote is that this indicates that 24% of the variation in the organic chemistry to final exam scores can be explained by the combination of the course format, the student demographics, and whether or not the student was repeating the course. So
yes.
Good. That's good enough for me.
For everybody else who's listening, if you're like, what does this mean? I'm not kidding. That probably took me 2 days to write that.
Yeah. Yeah.
And
see,
then the
everybody out
in
there,
the next paragraph, same thing. I was just like, what
you
does
can
this
be a
mean?
researcher too and not have to know what all this means. So
no, yeah, and it's, you know, find the people who know the thing to help you with it. You know, you don't all have to know everything, right?
Yes.
Right. But I mean, the general, okay, let me see how well I can explain stats here. But yes, you're going to have variability because of lots of different variables. That's a redundant statement, but you get the idea. So you're trying to say, you know, when we do these models, we're trying to say, can we figure out what amount of the variability we're seeing in the outcome can possibly be attributed to the things we're looking at?
Exactly.
That's the general idea.
You're always asking what can explain it? What other things can explain it? Right.
And as somebody coming from, like, I hate to use this term, but hard science, which is not a great term, but it's what's coming to mind right now. You know, we want R squareds of like 0.9. And I have to remind my colleagues often who don't deal with education research, like, we're dealing with humans.
That's right.
And humans are not often logical actors, regardless of what economists think they are, right? And so humans are complicated and messy. And so 0.2 is great when you're dealing with people.
Yes. Great. So you also went to your qualitative data, and I didn't, you know, table 8 was very large and had lots of detailed. And, you know, I'm going to say something that Bill says every time, which is I would really encourage everyone, this is an open access paper, to read this paper. If you're an educator out there, you're going to love this paper. It has all kinds of things for us in terms of, you know, references and great writing. I mean, it's really well written too. But the table 8 has the quotes from some of the quotes or example quotes from the questions in the post survey student survey about their experience. What did they think of it, and what methods they find helpful, and then how did it change your study habits? So I just want to point out that one of the most common things that people mention that they really enjoyed, methods that they thought were especially helpful, were podcasts. So just FYI, thought I'd plug that.
So self-satisfying.
That's not possible.
Yeah.
Podcasts are not useful.
Especially when we have Bill Toon. Okay,
Yeah.
so now
That's why I said I'm probably not really good for you guys.
we have
We
to have
love you. We love
do.
you.
We do. Cactus Bill. Okay, so this is just that summary table, though, the survey question. So you did the Likert scale as well. So you did a quantitative, and then you had the qualitative table, which is always too huge to put in a slide because it has all kinds of great quotes in it. So this must have been very fulfilling to read that the student perceptions were actually reflective of your actual, outcomes.
Yeah, it was great to see that that majority of people appreciated it. And I think this is important too when you're looking at what students think about classes, is to ask things in a few different ways, because how they interpret the question may not be how you interpret the question. And also for those of us like, me, I have to look at student feedback on my teaching regularly, and that one horrible comment is the one that stays with me for the next 10 years, when 90% of them were actually good.
You too. That happens to other people too.
Yeah.
Yeah.
So it's helpful to see, like, okay, did everyone love it? No. Were there some people who rated this 1? Yes. But on average, most people liked it. And it was, for some of the things we asked, it was stronger for the repeaters than the non-repeaters. Meaning the people who are benefiting from it in an outsized way are also the people who are appreciating it, which is helpful to know.
This is great. I think I'm still a little curious about, you talk about the comparison. So we compared final exam scores, course grades, pass rates, and the two models. And you mention many times culturally responsive teaching, promoting equity. I keep getting back to this sort of how, again, I'm really interested in seeing how people acted out solvent molecules and nucleophiles. That must have been fun. But how you flip, how the teacher, so much depends upon the teaching and the teacher. How that occurs probably makes a huge difference as well, rather than I can take a packet and this is flipping it by, you do this at home and we do this in here. So I'm really curious about that. Do you have more of a comments about like which elements maybe of the flipping might have a better impact than other elements? Because now it's like I'd love to know some of the details of the activities that are impactful, and not just perceptions of students, because we know that sometimes those don't match with outcomes. But what elements do you think might have been more culturally responsive than others?
So I think, again, a lot of the culturally responsive aspect, to me at least, and so Lynn is more the expert on this, but from my understanding of it is that I think what it is again pointing out you are not expected to be a completely autonomous, isolated learner, and that you can work together. We can talk through things. It's okay to ask questions. To me, that's what a lot of it comes down to. But the way I did it really varied depending on what I was doing what it is that they needed to learn. So acting out solvent molecules doesn't work for everything, right? Like there's a lot of things in organic chemistry that's really hard to do things like that with. But just bringing in a lot of different things. So for example, stereochemistry is a thing that people struggle with, myself included. So I guess maybe one of the things that I do that I think other people might want to try is just being really honest about what I struggled with. And normalizing that it's okay to have a hard time with things. Like I'm really upfront with my students and saying like there's certain things in stereochemistry, which is like 3-dimensional representations of molecules in 3D space, that I really struggled with as a student. I thought I got it, And I had skated by in undergrad, and I got to grad school and I was like, oh no, I actually don't understand this and I'm in trouble. And like,
Yeah.
honest about how I did it. And so I used model kits, which we have model kits. We tell the students to get them, but then no one uses them in class, or not a lot of people don't. So we used them in class, hands-on, together, and built them together. And sometimes you want to compare two models, but you don't have enough pieces. So I would have one student build one version, one build the other. And I said, okay, you each built something, now compare them. How are they the same? How are they different?
Yeah.
Right. And you can't do that alone because you just don't have a big enough model kit unless you want to buy two.
Yeah.
So just really thinking about like, what is it that students struggle with this particular thing, and how can I help them get through that?
And I love how you
and how can I
incorporated.
normalize that it's okay to fail?
Yeah, I love that you incorporate critical thinking. What's different from your model and my model? And when we did flipped with paramedics, the students each one of them brought their models, and then looked at each other's models and thought, oh, okay, this is how you represented this with whatever was available. They did kind of junkyard models where you were using anything you had, cardboard or whatever at your house. I'm so upset that time is running out because you're so smart and there's so many things that I'd like to learn from you. I do want to ask you though, quick, because you printed this, you published this in something called Chem Archives, and we don't have such a thing in EMS. So tell us a little bit. This is a preprint service. It's open access, so you can put your paper up there. But it's not quite, it's preprint, it's not published yet, and it helps chemists all over the world really be able to see what research is out there and get research out quicker. Whereas a lot of what we have to do is first of all, we don't have dedicated journals, that many of them, where we can publish our work, and second of all, it's very hard to publish in the journals that we have. So tell us a little bit about how this is helpful to chemists and what happens when you put it up there.
So if I understand the history of the preprint servers correctly, I think Archive was the original, and it was started by physicists. And this is actually not a new thing. So Chem Archive is relatively new. Chemists are just starting to get on board. BioArchive, I think, has been out for a while. But physics, I think, were really the pioneers of this like decades ago, like 20 plus years ago. And the idea is you can put out something you're working on when you think it's far enough along, that it could be publishable at this point, and get feedback from the community. I've gotten some feedback, which is interesting, but we are in the process of actually publishing it. So the idea is the preprint isn't necessarily, it kind of precedes a publication. So I'm actually looking, I have the paper up on my other monitor here because we are in what is hopefully the final round of minor revisions. Fingers crossed, it's due next week. We should just be just about done. So hopefully it will be officially published in a journal soon. But we wanted to just get it up on the preprint server, partly to get some feedback, which I got, but partly just because the publishing process can take a long time. And there were I would talk about this in conferences and people would ask me about it. So I thought, okay, well, I should just put it up here. And then also there's the issue of access. Like, as you mentioned, the preprint servers are open access, and open access publishing in official publishing channels is a challenge. So as I mentioned at the beginning, my major role here and my job is teaching, and the scholarship is kind of a smaller part. I don't have large grants or funding, and most open access publication requires pay on the author side, which I just don't have. So it's a little bit challenging for me to publish something in official open access capacity, but this was kind of a way to get the work out there for people who wanted to see it, who maybe don't have access to the official journal publications. And the journals are on board with this at this point.
Yeah, it's fantastic, because a lot of our journals will say you're disqualified from publishing it in our journal if you've already put it out there on some other format that people have access to, like you've already presented it and they want right of first refusal. So this system by which this doesn't hurt you for publication, it helps you, seems really, really like a great idea.
Yes.
And I just wish that we had that in medicine, paramedicine in particular. So really fascinating that's.
Sounds like a new project for you, Dave.
There you go. There you go. So
You
many.
know, it
I'm gonna
really
start
does
the
come from the
PRF
community.
archive.
It comes from the community pushing. The community pushed the publishers to make it acceptable. It really does come from the community banding together and saying, we want this.
Wow, that's good to know. Good to know. Thank you very much for joining us. Any final thoughts, David and Bill?
Well, I think there's another nail in the coffin that we already knew was big, which is we've got to, you know, if you keep insanity doing the same thing and thinking you're going to get a different result. Flipped classrooms are clearly giving us insight on how we can do better teaching, and this angle to it in terms of reducing that gap or eliminating the gap between students who are struggling is another way to show that this collaborative learning, this community learning really is promoting a new type of educational model that is working. And so I know it's hard to change, especially when you're a teacher. And here the example is, well, how can you do this with large groups of students? And Renee's doing them with 1,400 students. So don't come whine to me that you've got 42 students in a class and there's just no way that you can do a flipped classroom, because this is clearly going to help reduce the systematic barriers that we have for equity and diversity. And we owe you a great debt of gratitude, because you just walked through 5 years worth of your work and are reaffirming some of the things we're finding with tiny little projects that are small numbers of students and small number of hours, and congratulations.
Yes, your students are very lucky to have you, and we were very fortunate. Thanks, David, for finding Dr. Renee Link. We'll talk about that maybe at some point, how you ended up finding this article. This is a really great discussion. Thank everyone for joining us. We're going to continue to follow your work. The Pre-Hospital Care Research Forum Education Research Podcast will be back February 26th, 10 a.m. Pacific, noon Central. Remember, we're on the 4th Fridays, so you can mark your calendar ahead of time. The next Pre-Hospital Care Research Forum clinical podcast, though, will be back sooner than that, and that's on Mondays. That's on the second Mondays of every month, and the next one is February 8th, so we hope you'll join us for one or both or all of them this year. If you would like to present an upcoming article, or maybe you run into something really cool like this last one, email David Page at dpage@emsed.net. Thank you all for joining us. See you next time.